Parallel lines and slopes. Two lines in the same plane that never intersect are parallel lines. And the key point with parallel lines is that they have the same slope. So if you have equations that have the same slope, the graph of those two lines should be parallel to each other, meaning they will never intersect. Now, all vertical lines are parallel. And let's look at an example here. So remember, the key point with the parallel lines is that they have the same slope. So if I were to determine which lines are parallel from the graph here, all we have to do is find the slope of each line and see which of those two are have the same slope, right? So let's find the equation of each line given the 2 points of the lines. So the first line, line A, has a slope that is -1/5. Remember, the slope, we're using the equation of the slope y2 minus y1 over x2 minus x1. Labeling wise, you can label it however you want, right? This could be your x1, y1, and that would be x2, y2, or you can label this as your x2, y2, and this has to be the x1, y2. So remember, when it comes to labeling, you can decide which one is 0.1 and 0.2. And line B, using the 2 points here, we get a slope of -1/4, and line C has a slope of -1/5. Now, to determine which lines are parallel, all we have to do is compare the slopes. Which of the two lines have the same slope? As you can see here, line A and line C, they both have the same slope. So that means lines A and C have the same slope, meaning they are parallel to one another in this case. Now, let's look at this example one here. So in this case, we want to find a new equation that passes through the point 5 comma -4 and is parallel to the given line here, which is y equals 2x plus 3. So the line or the equation that we're given is this. I want to find a new equation that is parallel to this and also goes through the point 5 comma -4. So what I know from those 2 points is that they have the same slope because we're looking for the parallel line. So solution to this would be, well, first, let's figure out what the slope is. Well, the given equation has a slope of 2, right? That's what I have here. So the parallel line that passes through 5 comma -4 should also have a slope of 2. Now, the only difference between those two lines is their y-intercept. All right, this goes through the +3. This one, we're going to have to figure out what the y value is, or the y-intercept, I should say. So what I'm going to do here is use the point slope formula, which is y minus y1 equals m, the slope, and then x minus x1. Well, from here, we know that the slope is going to be 2 because it's parallel to this. It should have the same slope. Now, the x1, y1, well, my x value is 5. And then the y value, y1, would be -4 in this case. We know that minus and a negative makes positive, so that turns into y plus 4. And then over here, I can distribute the 2. 2 times x is 2x, and 2 times -5 is -10. Now, to find the equation, I need to isolate the variable y. So we're going to subtract 4 on both ends. You get y equals 2x minus 14. And this is what we call the intercept form. So this equation and this given equation here are both parallel lines. If I were to graph them, they will never intersect, right? And they both have a different y-intercept. Example 2, very similar to that. Let's try to find an equation that is parallel to this and passes through the point -1 comma 4. And of course, it's parallel to this line. So what we know from here is that the equation of the original, or the slope of the original equation, is 3. So that means the line that passes through that -4, 4 should also have a slope of 3. Using the point slope formula, we have x1 is -1, and then y1 is +4. And of course, our m, the slope, is 3. It's the same. Now, over here, you get a y-4 equals, before I distribute, this turns into a positive because two negatives makes positive. So we have y-4 equals 3x plus 3. To isolate the variable y, we're going to add 4 on both sides. And that will give you y equals 3x plus 7 as the final answer. Now, perpendicular lines. And the key with perpendicular lines is that two lines that are perpendicular make a right angle, meaning the angle where they meet is 90 degrees. And two lines are said to be perpendicular if and only if their slopes are negative reciprocal of one another, or the product of the two slopes is equal to -1. Vertical lines are perpendicular to horizontal lines, because if you draw those two lines, you would get a 90-degree or a right angle at that intersection point. Now, an example of perpendicular equations. Let's say I want to find an equation that passes through the point -3, 1 and is perpendicular to y equals 1/2 x. Now, the key point with the perpendicular lines is that their slopes, the slope of this equation right here and the slope of that perpendicular line, should have the negative reciprocal of the slope. The reciprocal of 1/2 is 2/1, which is 2, and the negative of that would make it a -2. So as you can see here, the graph of the given equation, which is this equation right here, has a slope of 1/2. So a line that is perpendicular to this should have a slope that is negative reciprocal of that slope right here. Well, the negative reciprocal of 1/2 is -2. So the new slope in this case would be -2. Using the point slope formula, we have y minus, my x1 is here, y1, and the slope, of course, is a -2, right? And the minus and the negative will turn into a positive. Distribute the -2 over, you get y minus 1 equals -2x minus 6. And then we're going to add 1. -6 plus 1 is -5, so you get y equals -2x minus 5. This equation is in intercept form. Example 4, similar to what we did. In this case, the equation or the line is passing through the point 4, 3 and is perpendicular to this. Well, the original slope, as we can see here, is +3. So an equation that is perpendicular to this should have a slope of -1/3. Remember, 3 could be written as 3/1. The reciprocal of 3/1 is 1/3, and we want the negative of that. So the graph of the equation here has a slope of 3. So that means the perpendicular line should have a negative reciprocal of that number. In this case, that new slope would be -1/3. Using the point slope formula, we have the following. Right? The new slope is -1/3. X1 is 4. And then, of course, y1 is 3. I'm going to distribute the -1/3 over. Negative times negative makes positive, and of course, 1 times 4 is 4, and then divided by 3. Next step would be to add the 3. So you get y equals negative 1/3 x, and if I combine those two, we get 13 over 3. So the final answer in slope-intercept form would be y equals negative 1/3 x plus 13 over 3. And again, two lines are perpendicular if the product of their slopes is equal to -1. That is, if I were to multiply a negative 1/3 by 3, I would get a -1. And that tells me that the two equations are perpendicular to one another. Example 5 is a little bit different, and that's because the y variable is not isolated in this case, right? We want to find an equation that is perpendicular to this, but passes through the point 4 comma -2. So first, we're going to rewrite this in terms of y equals mx plus b. That is, we're going to isolate the variable y. So we'll start with this. First is we're going to move the x over to the other side. Remember, if you move the x over to the other side, it becomes the opposite sign. So you get 3y equals negative x plus 6. To isolate the variable y, we're going to divide by 3, divide by 3, and divide by 3. And notice here, you have a -1 times x here. So if I divide by 3, I get a -1/3. 6 divided by 3 is 2. Now from here, this equation here and this original equation are the same, right? Except that this equation is written in the y equals mx plus b, where the y variable is isolated. Now from here, you can tell what the slope is. The slope in this case is -1/3. So if I want an equation that is perpendicular to this, it should have the opposite sign, which would be, it should be positive, and then the flip-flop of those numbers. So it should be +3 in this case. So any line that is perpendicular to this should have a slope of +3. Because the point 4 comma -2 is on the line with slope 3, we can use the point slope formula to find the new equation. Point slope formula. Now let's substitute our x1 and y1 as well as the slope into this equation here, which looks like this. A minus and a negative makes positive, so you get a y plus 2 here is equal to, if I distribute the 3, I get a 3x minus 12. And of course, to get y alone, or to isolate the variable y, we're going to undo the +2, right? We're going to subtract 2 and subtract 2. If I subtract 2 here, the 2's cancel. Over here becomes more negative. So the final answer in this case would be y equals 3x minus 14. And you can always double check. Remember, perpendicular means the slope of the two lines. If you multiply them, you should end up with a -1. If it does not equal to -1, then the two lines are not perpendicular to one another.